Welcome back. We are going to go ahead and move on to Unit 2, which is all about equations and inequalities. So I know a lot of you are going to be happy about this. You're going to see some things that actually look familiar to you, but don't worry, those exponents and radicals, you'll continue working with those because we want to master those concepts. So in this unit, we are going to start off with identifying properties when solving equations. What allows us to do what we're doing when we're isolating x. So go ahead and pause this video and either print or copy your outline, and then when you're ready, click play. Alright, so we have been given, 6 algebraic equations, and they want to know which properties are we going to use to solve them. Now, what I would do is go ahead and make this little diagram right here a flapper, and then if you want, you can do any work underneath it, so you don't have to do it off to the side. Completely up to you. Alright, so we are given, now remember, we do not read this x over 3. It is x divided by 3 plus 1 equals 7. Now I'm going to read that again, and I want you to pick out what are the operations that we're using. So x divided by 3 plus 1 equals 7. So I had a divided and a plus. So that tells me I'm going to have to undo the division and undo the addition. Now, when solving an equation, we're so used to following order of operations, PEMDAS, but when solving equations, when we get down to isolating the x, most of the time we're trying to do PEMDAS in reverse. We want to undo any addition and subtraction first, then we're going to undo any multiplication and division. So, let's follow that logic. I'm going to go ahead and work this out to the side. You can do that as well, underneath, whatever you want to do is fine. Okay, so x divided by 3 plus 1 equals 7. So following what I was saying, when we are isolating the variables, so variables on one side, numbers on the other, I'm going to think of PEMDAS in reverse. So I'm going to undo any addition and subtraction. So first I'm going to undo this plus 1, and its inverse would be minus 1. So I get x divided by 3 equals 6. So what property did we just use? We just subtracted from each side, so that is the addition or subtraction property of equality. Now, what I want to bring up real quick, when you're looking at a testing situation, if there's a drop-down menu and you subtracted but you only see addition property of equality, remember, they're universal because I can make any subtraction problem I can turn into addition. Add the opposite sign, plus a negative. So there's often times where you'll only see one of the words, and that's okay because addition and subtraction, they're universal. So let's go ahead and continue. X divided by 3 equals 6. So x divided by 3, so the inverse of division is multiplication. So we are going to multiply both sides by 3, because what's anything divided by itself? 1. So x equals 18. Okay, so what did we just use? Multiplication property of equality. Again, and it's multiplication or division, because I can multiply by 3 or divide by 1/3, which would be the same as multiplying by 3. So they're all universal, it's just different ways of writing them. Again, you can keep this work, or if you know what you're doing, you can kind of put it on here. It's up to you. These are your notes. So 4x minus 3 equals 5. Alrighty, so let's read that again. 4x minus 3 equals 5. 4x minus 3. I only hear minus 3, so I only hear one operation so far, subtraction. But I know there's something else going on because it's not just x, it's 4x. So what operation is in there? 4 what? 4 times x. So I have a multiplication and subtraction that I need to undo. Alright, so again, PEMDAS in reverse. Let's undo that addition and subtraction. So since we're subtracting 3, we are now going to add 3. So 4x equals 8. So we just use the addition property of equality. And come back over. Now, again, 4 times x, so instead we are going to divide by 4, because anything divided by itself is 1, so we are left with 1x equals 2. So we use division. All right. What I want to bring you guys back to, whenever you are solving equations, if you have extra time, please plug in your answer and make sure it works. So if I plug this in, 4 times 2 is 8, 8 minus 3 is 5. How quick was that to check? Super quick. So when you're in a testing situation, because a lot of you are really good at solving equations, so you fly through these problems. The problem is when we're flying, we happen to make a small arithmetic error, drop a negative somewhere, and boom, we just got the whole problem wrong for a silly arithmetic error. So when you have time at the end, go back and plug in. Take that 18. 18 divided by 3 is 6. 6 plus 1 is 7. Again, it's a quick check. Make sure it works. All right, so this next one, how would we read that? X what? Divided by 5 equals 5. Okay, this one's tiny, so I'm going to keep it over here. So x divided by 5, we only have one thing to undo. So what's the inverse of division? Multiplication. So x divided by 5, so we're going to multiply by 5. So x equals 25. Easy peasy. So what was the property of equality we just used? We multiplied both sides by 5. Now, that is why, that's what's significant about these properties of equality. Properties of equality. We're doing it to both sides. What you do to one side, you do to the other. That makes it a property of equality. It is keeping our equation balanced. So that's why it makes it a little bit different than distributive property, commutative, and associative properties. So we'll get there in a second. All right, so let's come back. X plus 3 equals negative 7. X plus 3. So the inverse would be subtract 3. So x equals negative 10. Now this is where you guys have to be very careful with your integers, all right? Keeping those positives and negatives straight. Because if I plug this back in, negative 10 plus 3, that does equal negative 7. But if you would have messed something up and said, let's see, what's a common mistake? Negative 4. Negative 4 plus 3 is certainly not negative 7. I have people that will say positive 10, completely dropping the negative. 10 plus 3, again, is not negative 7. Such easy things that we can catch. All right, so what property did we use? Subtraction property of equality. All right. Ooh, this one's got a couple more steps, so I am going to move off to the side to show my work. 2 times the quantity x minus 2 equals 30. 2 times the quantity x minus 2 equals 30. Yep. All right, remember, when we have parentheses, that's how we read it. 2 times the quantity x minus 2 equals 30. Now, when you solve equations, if you are a steps person, like you like to look at it and say, okay, I do this first, I do that next, and I do that next, then look at these steps. Okay? First, if there is ever a time where you need to distribute, that is what you are going to do first. Now, there is another option that will still give you the correct answer. Okay? There is. However, it doesn't always make the problem simplify nicely. That's why it's not something that I include in my steps. But yes, there is another way to solve this for x. So, just rule of thumb, steps that I like to take. First, I like to distribute. Then I like to CLT, combine like terms. Okay? After I combine any like terms that there are, then we isolate. We isolate that variable, which means we get it by itself. So all those variables stay on one side, everything else gets kicked over to the other, and we use inverse operations to do that. So first, we start with distributing. So what are we going to distribute here? We're going to distribute this 2. So 2 times x gives us 2x, 2 times negative 2, negative 4, equals 30. Now, something I've seen other teachers do that I really like if we have a lot going on with an equation is they put that line down to show when they're using properties of equality that they make sure you do it to both sides. Now here we just distributed a 2. We are not using a property of equality, so we only did it to the left side because only what's in the parentheses is being multiplied by 2. Now when we look at this, what do we have going on? Oh wait, I don't want to forget, so I'm going to come over here and mark off distributive Oh, I did that in blue. Distributive property. Okay, now I'm going to come back over. So we have 2x, or 2, what's that operation again? 2 times x. So 2 times x minus 4 equals 30. Okay, so let's isolate that variable because there's no terms to combine. 2x and negative 4, those are not like terms. So we're just going to isolate x. So inverse operations, PEMDAS in reverse. I'm going to undo any addition and subtraction. So I'm going to add 4 to each side. So we get 2x equals 34. So I just use that addition property of equality. And let's see what's last. So again, 2 times x. So to undo a multiplication, we are going to use its inverse and divide. So divide both sides by 2. So x equals 17. So let's see. Let's plug it back in and check real quick just to make sure we didn't make any arithmetic errors. So 17 minus 2 gives me 15 because I do what's in the parentheses first. And then 15 times 2 gives us 30. Awesome. So let's go ahead and check off that division property of equality. And we used 3 different properties that time. Awesome. Okay. So 10 minus x equals 49. 10 minus x equals 49. Okay, so I ask myself, is there anything to distribute? Just a 10 and a negative x, so nope. Are there any like terms? So when I think about like terms, on my left side, are there any like terms? 10 and a negative x. No, there are not. 49, well, it's by itself, so nope. So now we're going to isolate this x by using inverse operations. All right, now how do I get rid of this 10? When you're looking at something and there's not an operation, so there's not a plus, minus, multiply, or divide in front of the number, ask yourself, what kind of 10 is this? It's a positive 10. Okay, so what's the inverse of a positive 10? A negative 10. Does that make sense? Because 10 minus 10 is 0, it would cancel it out. So again, what I do to one side, better do to the other. Those properties of equality. So we have, don't you drop this, we have a negative x equals 39. So I just use subtraction property of equality, so I'm going to fill that in my table. And we've got negative x equals 39. So this is not solved. Do not tell me, if you were solving this, that x equals 39. No, it doesn't. Negative x equals 39. How do I get rid of this negative sign right here? Well, let's think about it. If I were to put a coefficient, a number in front of that variable, what could I put there? Instead of just writing a negative x, negative how many x? Well, it's negative 1x. Okay, so now negative 1x equals 39. What operation is being used? Negative 1 plus? Nope. Minus? Nope. Negative 1 times x. So we use our inverse operations. Inverse of multiplication is division, so we divide both sides by negative 1. So x equals negative 39. Well, let's go plug it back in. 10 minus a negative 39. I don't know, what is it that you guys say? Same signs comes to addition or something like that. Keep, change. But 10 minus negative 39, so thinking about it on a number line, if I start with 10, if I subtract negatives, I'm actually going in the positive direction. So yes, I would end up at 49. That works. So I need to go mark my division property of equality. Okay? So when solving, just keep in mind what properties are we using, because that is why we are able to get that variable by itself. All right, so just one more. You don't have to print this out. I just kind of want to go through this. Where did Wally go wrong? All right, so if we look at this, I don't know why that says type equation here. Oops. Okay, so complete the algebraic proof. So Wally came up with your given. So your given is what the statement that you are given. So 2 times the quantity x minus 3 equals 18. Hey, we solved this, so we know how to solve this. What was the first thing that we did? Now, Wally says to use the multiplication property of equality. Well, what do you think he multiplied here? Because I'm looking at this and I know that my steps tell me first thing I want to do is I want to distribute. Is that the multiplication property of equality? No, it's not, because the multiplication any property of equality is an equality property, which means what we do to one side, we do to the other. It's keeping the equation balanced. Distributive property does not do that. So this proof is wrong. This should be the distributive. Actually, I'll write it off to the side because that would look confusing. Because we are only distributing the 2. So then we end up with 2x minus 6 equals 18. Okay, let's make sure that he did everything else correctly. So here he says addition property. Well, what's he doing with the addition property? What's he adding? He's adding the 6. So that makes sense. If we add the 6, we would then get 2x equals 24. And then division property. Well, he's dividing by 2. So x equals 12. So what's 12 minus 3? 9. 9 times 2 is 18. Maybe this isn't exactly the same as the one we did. Nope, it's just similar. So those two are both correct, but he did make a mistake, because the multiplication property of equality would be if we were like multiplying both sides by a 2. We didn't do that. We just distributed the 2, which is just a form of simplifying the equation or expression. All right, well, I hope that makes sense. I want you guys to go ahead and start that day 1, and let's see how you do.